Good evening, everyone. So last video we were talking about adding big brakes to your car. We took some critical key dimensions, and now the question is, what do we do with it? So this is a picture from the last video, and you might want to use something like this to kind of get an idea of how to draw your brackets. And later on we'll be using SolidWorks, but for right now let's just kind of get an idea of how to go about this. So here is the spindle with the mounting ear. This is the caliper, and for us, we're going to have to mount the caliper on top of the bracket. It's a radial mount caliper, not an axial or a standard mount. So what I like to do first is just draw it out. Just kind of draw with an idea so we can actually go ahead and design it later on. So after drawing it out, this is kind of my plan, and I'm going to mount the bracket to the spindle here, and I'm going to mount the caliper to the bracket here. And here are the two bolt holes I'll be adding. They'll both be threaded. This is going to be a blind hole, and this will be a through hole. And the reason I'm making this a blind hole is this is probably going to go near the area where this is threaded. So I'm going to make this a blind hole, make this a through hole. That's kind of my plan for now. So let's go ahead and take a look at the finished part. And this is my first prototype. And from here, I would like to 3D print it and then go ahead and mount it on the car. But how did we get to this point? Well, let's go ahead and make a new one. So some people like to start out with a shape and then start removing material. Some people, since they already have the idea in their head, they'll just go ahead and start drawing it right off the bat. Sometimes you just kind of wing it. So for this one, I actually wound up drawing from stock material first, and let's just go ahead and do it that way. So I'm going to start off by making a square. The material I'll be using will most likely come in a square shape, so let's go ahead and use that. And from the last video, we took some maximum dimensions. So we took this dimension, which will be the overall length, as being 6.5 inches as the max. And the height we're talking about, actually we didn't have a height dimension, that's for us to figure out. And we were talking about the thickness of it being a maximum of 1.6. And the problem with 1.6 is the basic material comes in 1.5 inches and 2 inches. So you either get a 2-inch piece and you machine it down to 1.6, or you just go ahead with a 1.5-inch piece. Since the width of it's not critical, doesn't need a machine surface or anything, I'm going to go ahead with 1.5 and leave it at that. So this is our stock material. This is what you might wind up buying and then milling it down. So let's go ahead and start with this. So I'm going to work on the first dimension, and this dimension is going to be the mounting ear holes of the spindle. So let's go ahead and draw two circles. And if you recall from our critical dimension, it was 5.153. If you recall from our critical dimensions, it was 5.153. So I would like to put that in the middle of this piece here. So Alright, as far as the hole size, I'm going to go ahead and put it to the tapped hole size, the drill size for the tap hole. And the reason why is if I do a through hole, I would have to put a nut on the back. And when I 3D print this, I'm going to actually do the tapping myself. I'm not going to have the 3D printer do it, even though it's capable of it. I'd rather run a tap through it myself. So the actual size of the drill will be 27/64. That is a drill for a M12 by 1.25. So now another critical dimension that we gathered from the previous video is the location of the hole to the top of the bracket or the bottom of the caliper. And if you recall, that was 0.897. So right off the bat, here you got some 2 holes located in the proper locations, at least for the prototype. You can always readjust them later. So let's go ahead and just cut that through. Alright, so now you're looking at this and you have a lot of wasted material here. So let's go ahead and just trim up the fat on here. Alright, that looks pretty good just for a basic size. You have enough material here to be able to bolt it on and have it pretty strong. You gotta keep in mind this area from here to here has to be somewhat substantial, and the reason why is that you have a bolt running through here, which is essentially a pin, and when you apply the brakes, this bracket's going to want to rotate, and it's going to rotate and it's going to press against this area right here. So this area has to be strong enough not to deform. So right now it should be about 1/4 of an inch, yeah, a little bit over. And this actually is probably too big and it might have a hard time bolting onto the caliper. But I'm going to leave it for now and we'll kind of see how it goes from here. So let's go ahead and cut this out. And I'm actually going to cut everything else out around it. So now I have a basic bracket. First problem with this is sharp corners are bad news. They actually promote cracking. So what I'm going to do is just add two radiuses here, and probably about 1/2 inch. Let's just see how that looks. Alright, that's pretty good. And if you're doing this manually, you can use a 1-inch end mill to cut this out. You're going to have a hard time with these, but you might just want to leave them squared off, just depending on what kind of equipment you'll be working with. If you're going to get these CNC'd or you're going to get them water jet or lasered, then you can have any design you want. Alright, so the next thing we're going to do is we're going to want to cut this pocket out. And if you recall from this picture, of this pocket milled out, and by doing that it's going to actually locate the bracket in relation to the caliper. So one thing I forgot to do is on the previous video was from this bolt hole on the caliper, measure it from here to the back of the ear on the spindle. And that would have been pretty difficult in the position I was. If the spindle was off the car, you'd probably get a good measurement. But I'm going to take a good old college try and try to figure this out. What I can gather is that the hole is in the middle of the caliper, and the middle caliper extends past the ear. So if this is 1.5 inches, this has probably got to be around 3/4 of an inch in the bracket. So this might be a 1/2 inch, and then a 1/2 inch, and a 1/2 inch. So I'm probably going to cut this hole out, or this pocket out, probably about a 1/2 inch, and then I'll put this hole maybe dead center, and we'll kind of go from there, and I'll adjust it as I go. So let's cut this pocket out. And as far as material here, I'm going to leave something somewhat substantial. Doesn't need to be too big, but you want to leave something that's not too flimsy. I'm going to go with 300 thousandths. Alright. So once again, if you have the ability, you might want to go ahead and add a radius here. You're going to have kind of a hard time depending on the tooling you're using. If you're using just a regular end mill, you're going to be cutting straight across, and you're actually going to have a sharp corner here. If you happen to use an end mill with a radius on it, then it'll be whatever that is. So if you can, try to find something, maybe with an 1/8 inch radius or something, or even a 1/16 of an inch, just to get something there. If not, it's not the end of the world. You don't have all your force is not going to be on this surface. It's just food for thought. So the next thing is you want to add the caliper mounting holes, and like I said from this picture, it might be halfway in between in relation to where this sits now. So I'm going to put it halfway between, and if I need to adjust anything, I'm actually going to adjust the pocket to slide the whole bracket inwards or outwards. So like the other holes, these are also M12s. So I'm going to go with a fine thread M12 by 1.25, and it's going to be another 27/64 hole. And the critical dimension on that was 5.116, and that would be the mounting holes on the calipers. So at this point, and it's only with this design, if you have a caliper that mounts farther in, and you can do a through hole and it won't affect anything. If I cut all the way through, I'll actually wind up putting a hole right in the center of where my other my through hole is for the spindle. So I'm not about to do that, and the reason why is you'll start to lose a lot of structural integrity. It'll actually be pretty tough to work with and machine. Yeah, there's a better example of what it looks like. So what I'm actually going to do is drill the hole probably down to about here, and you want to leave, I don't know, maybe about 100 thousandths or so of material just to keep a nice thick wall here. But you want to have this deep enough so you can actually drill it and then tap it and have enough thread engagement. So let's see what half inch looks like. Half inch isn't bad, and keep in mind when you're drilling, you're actually going to have a point on the tip of the drill bit. And then when you're tapping it, depending on what tap you're using, if you're using bottoming tap, you'll actually be able to get near the bottom, but if you don't have a bottom tap, then your threads are actually going to end a little bit higher up. So depending on what equipment you have to really make a decision on how deep you want to cut these. So half inch seems to be pretty good. I could probably get away with a little bit deeper. Let's try 600 thousandths. Yeah. $600,000 isn't bad. Not too big of a fan of this thin wall right here, but just kind of the prototype. If I actually need to shift this direction to push the bracket out, and that would actually be pretty good for me. If I can't do that, then I might have to reconsider changing the height of this to make it a little bit thicker, so this doesn't interfere. So the bolt hole doesn't interfere with this flange. But like I said, we're in prototype stages, and you can get away with trying some stuff out. Just want to make sure that your final design is going to be strong enough. These are brake brackets, you know, they're not a trinket. So you definitely safety first. I'm going to go ahead with it. I'm going to mount it up because I want to get some dimensions and see how everything lines up, and I can adjust everything. So at this point, I'm going to throw it in the 3D printer, and I'm going to thread the holes. Well, sorry, tap the holes, and then I'm going to put it on the car. So let's go ahead and check out the software for the 3D printer. So I'll go ahead and add the part. Now, key with the 3D printer is you want to actually have the flattest surface facing down. So this bracket can actually be printed two different ways. One with this surface on the bottom, or two, this surface here on the bottom. Both will work. So let's just go ahead and flip the part. So this is good since I'll be printing in ABS. As long as I print a nice brim around the material and this doesn't warp, this surface will actually be pretty flat. ABS is prone to warping. If you use PETG or PLA or something else, you don't have to be as worried about warping. But since I print a lot of ABS, this is what I'm going to choose to do. And there's a lot of settings. This isn't a 3D printing video, but I'll just show you what it looks like after we do something called slicing. And slicing will actually do layer by layer and show you exactly what the printer is going to be doing. That looks pretty good. So let's go ahead and print it, and I'll show you guys what that looks like. Alright, so now that it's done printing, took about 7.5 hours. Let's have a look up close.
Alright, looks pretty good. There's actually seems to be almost no warping at all on the ABS, which is great. So that means I had good bed adhesion and a nice sized brim around it to keep it from popping off. So let's go ahead and pull it off. So the next step at this point would be to test it on the caliper, make sure it bolts on, and then go mount it to the car and see what it looks like. So after you have your prototype finalized, how do you proceed? So you can CNC it, you can manual mill it, you can do a water jet or laser. And my method is to get a water jet to cut out the basic design, and I can do the finish milling on it. So this is the bracket that my first design was based off of, and I went ahead and got a steel bracket cut with a water jet, which looks like this. So this is 1.5 inch thick steel, and this was actually cut with a water jet. They can actually do about 6 to 8 inches, but for 1.5 inch, it's very reliable as far as the dimensional accuracy. So what I'm going to do is I'm going to actually cut the pocket out with a mill, so you can see what it's lacking. So this pocket right here, I'm going to have to mill out on this bracket, and the 2 holes on top, drill and tap. And I chose to do it this way because the basic shape was actually going to be very hard to cut with the manual, and I don't have access to a CNC. So I decided to do a water jet because I do have access to that, and I can do a manual mill operation to clear the pocket. So that's my method to this madness, and this will be my prototype for the front brakes. So I'm pretty excited about this, and you'll see this in future videos on how this progresses as well. So anyways, stay tuned for future updates, and happy building.